So in this week's topic, we're going to talk about arrays and what we can do with arrays, what purpose do they serve in programming, and it's sort of going to serve as a gateway to the idea of a data structure, which we have a whole course here at CCAC defined to data structures, but this is sort of the first in that process. We're going to talk about a different way to store data. Now you're probably thinking, right, I know how to store data, and yes, we've done individual pieces of data. We've talked about how to store variables. I mean, we've been doing it since the beginning of class. This code on the screen should look very familiar to you, right? We have been using variables since the start of class. I think week 2, as a matter of fact. But there's more to it than that. What if we wanted to store more than one item? What happens when we want to store 20 or 50 or 80 items and we want to store them together? Do we have to define 20 different variables? And how do we manage all those variables and the data that goes in them? Every time we want to access them, do we write 20, 50, 60, 100 lines of code? That's sort of an interesting question, right? What happens when we want to do more? What I'm referring to is a list of data. Here you see a list of numbers. We need a way to deal with lists. We use lists for everything. There are multiple ways to deal with lists in programming, and we're going to look at just one way. In Java, Java provides us with a structure to deal with lists of data, and it's called an array. So in this lecture, we're going to talk about 3 major things. First, we're going to talk about how to define an array. What is an array? What is it used for? Is there stuff about it that we need to know before we go into using it? What kind of problems does it solve? That sort of thing. We're going to talk about how do we create. That should be lists of data, or lists or arrays. I put of in there because I wasn't thinking when I wrote this, of course. But how do we create lists or arrays? Okay. And finally, we're going to talk about adding data to and working with data in arrays. Now, throughout this discussion, you may hear me say lists of data or lists instead of the word array. Because essentially, I mean, conceptually, an array is nothing more than a list of data. But I don't want you to get confused, because arrays are just one of many ways to store and organize a collection of data. There are other structures out there, including one called a list. When I say list today, I am not talking about the list class that's available in Java. That is nothing more than a way to store and arrange data. What I am talking about is an array. Okay? So for the purposes of this discussion, when I say array, when I say list of data, I mean array, because conceptually an array is just one of many ways to store a list of data. So what is an array? Again, conceptually, an array is nothing more than a list of data. Here we have a list of strings that make up a to-do list. And this could be stored in a program in an array. What kind of data can we store? We can store any kind of data in an array. We can store strings. We can store integers. We can store doubles. We can store floats. I mean, integers, right? Whole numbers. Doubles and floats. Decimal numbers. Strings. Collections of characters. Objects, even. Yes, objects of other classes. We can have lists of objects. I could have lists of student objects if I wanted. It's actually rather quite impressive. Now, there is one caveat to all this that I need to let you know about. And that is that all of the data in the list must be the same. I can have a list of strings, but I can't have a list of strings and a list of doubles. I can't have strings and doubles intertwined. One or the other. You have to pick. Everybody asks this question, how big can our lists be? And my little hands here, $5 foot long, right? $5 foot long, right? Foot long. Length. Michael, I answer that question with another question. How big can my list, can my array be? And I answer that question with another question. How much RAM do you have? How much working memory do you have available? Because that really, the capabilities of your system are going to determine how big your array can be. One thing that we need to know about, though, just like once we have to, all of the data in the list has to be of the same type. There is sort of a caveat with size of the list. Once we've got the list a set size, we can't change it. We can't change it. So we can't make it shrink. We can't make it grow. Once the size has been set, we can't change it. It's okay to have not to use the entire list, all of the spaces available in the list, but it's not okay to try to put more in the list than you have room for. So it is important that you at least make the list big enough to cover the stuff that you want to put in it. All right, so we've talked about what an array is, and we've talked about its basic rules. So let's take a look at how we can create this array in Java. There are two different ways to create an array. We've got two basic, slightly different paths that we can take when we're creating an array. The first is creating an array that doesn't have anything in it, or an empty array, or an empty list. And the second way is to create an array and provide it a list of values to be inserted into it automatically. So essentially we're creating an empty array, or we're creating an array and initializing it to a value. But the process and the things that we need are the things that we need, and the syntax, the way it looks, is a little bit different. What I have here for you is an example of an empty array. This is sort of a visualization of an array. When I think about an array, when I represent one on paper to just make sure that my thinking is correct before I start writing code, this is sort of what it looks like. It looks like I've taken a row out of Excel, and every little cell is a spot in the list. And that's about how the computer stores it in memory, if we were able to draw it out. And this would be a visualization of an empty array. Now the question is, what information do we need to create an empty array? Well, the first thing that we have to know is the type of data we want to store. Again, we can store any type of data. Strings, integers, doubles, floats, even objects. And we also needed a name. You know, just like every other variable, we still need a name. So maybe our array or our list is called grocery list, right? This is something that I'm recording this on a Saturday, and Saturday is my grocery day. Saturday evening, in the early evening, I go out to the grocery store and buy all my food for the upcoming week. And so maybe I have an array called grocery list that stores all the items I'm supposed to get at the grocery store. On Sundays, I tend to get ready to do my to-do list for the week. Everything I want to do for the week, I start laying out what my plans are for the week and what I have to do. Maybe I have an array in my in a program called a to-do list. That helps me keep track of all of the lists of things I have to do. Maybe I'm trying to do some statistical analysis on a test that you recently took. Maybe I'm trying to do a statistical analysis on your midterms. Or a statistical analysis, I can't even talk today, a statistical analysis on your test scores. And so I create a variable name called student scores that hold to reference my list. These are names that we create, and they follow the rule for regular variable names. We want to make them descriptive, start with a lowercase letter, on and on and on. Finally, I need to know the size of my list. I need to know how big I want my list to be. I want to make it big enough to hold everything, because I can't make it bigger. So I want to make sure that it is big enough to hold all of the stuff that I want to put in it. Let's look at an example definition. All right, a lot of this is going to look familiar. Some of this is going to look pretty new. First of all, we have the data type. The first item is the data type. I'm storing a bunch of integers between -2 billion and +2 billion, so I'm using the data type int. Student scores is the name of my list. The square brackets that you see are actually tell Java that this is going to be a list of integers. Of course, we have the equal sign because we're going to assign a value. Now, what you're going to notice is the new operator. Well, wait a second. We're dealing, you know, with variables. We didn't use the new operator. We only used it with objects. And you're right. However, Java stores arrays as objects. As I said, Java stores arrays as objects, so we are going to have the new operator being used here. The second part of this, you see the data type again, a set of square brackets, again, letting Java know this is going to be a list with a number inside of that. That number is the size or the number of items that are going to be in this list. So essentially, I'm setting up an array of student scores that's going to allow me to put 20 items in it. And it's going to be an empty list with 20 items. Again, int is the data type, the variable name, along with the square brackets that let us know that it is a list of student scores. Equals new, because Java does treat arrays as an object. The data type again, another set of square brackets, and this time we have the number of items in the list. Now, it's got to be an integer. That number has to be an integer. We can't have half an item. That's like I can't give you half a pencil. Well, I guess I could. I can't give you half a human. You know, you either have a human or you don't have a human. I love these studies that say they have 2.5 children. The average family has 2.5 children and 1.5 pets. It's like, yeah, so which half of the pet do you have? You can't have half an item in a list. You either have an item in the list or you don't. So we're dealing with integers here. And you don't have to use a number. You can use a variable that results in a number or some sort of mathematical operation that results in an integer. As long as the result is an integer, you can stick it in that size column. It's okay. The other way to create an array is to create an array that is filled with items. Okay, what you see in this list is a visualization of an array filled with integer values. So what I might have done is created the student scores array, and this time only given it 6 and provided it with 6 scores right off the bat to put in the list. What do we need to know for this? Again, we need to know the data type, right? Strings, integers, doubles, floats, even objects. We have to know the type of data that we're looking at or that we want to put in. We also need a variable name here too. So is it grocery list? Is it to-do list? Is it student scores? Is it students? What is it? What are we putting in the list? Finally, instead of knowing the size that's in the list, we want to know the items that we want to put in the list. One note of warning here. The size of the array is going to be dictated by the number of items you load up. If you load 6 items, you're going to get a list with 6 spots. If you load 12 items, you're going to get a list with 12 spots. It all just depends, okay? However many items you put in there, that's how many you're going to get. Let's look at an example array definition that creates student scores with a list of items. Here again, we've got 5 integers. So I'm going to create a list of integers that stores 5 items. Not 6, not 12, not 20, but 5. Why? Because there are 5 items here. How do we set this up? Again, we need the data type, the very first thing. Since I'm storing numbers, whole numbers, between -2 billion and +2 billion, I chose to use the data type of int. Student scores is the name of the list because that's what I'm storing in it. I'm storing scores. The square brackets after student scores lets Java know this is an array. I set it equal to, and then you see the list, the comma delimited list of numbers inside the curly brackets. The curly brackets here tell Java that this is a list of values. 75, 95, 60, 85, 100. Most people did pretty good on this test. Each item for the list is separated by a comma. So I have 75 goes in the first spot on the list, 95 goes in the second spot, 60 goes in the third spot, 85 goes in the fourth spot, and 100 goes in the fifth spot. Okay? The curly bracket marks off the list of items I'm sticking in the array. And again, just to follow up one last time, right? That list is determined, the number of items in the array, the number of spaces to put stuff in the array is determined by the size of that list. If I have 20 items in that list, then I'm going to have 20 spots in my array. If I have 5 items in that list, I'm going to have 5 spots in that array. And remember, you can't change the size once the list has been created. Now that we've talked about working with or creating arrays, it's time to talk about working with the arrays. Getting data out of, putting data into. How do we do that? And what are the ways, what are the things that we have at our disposal? Again, I want you to think about, when you're thinking about an array, I want you to think about it like this. Now, this is a little different than the way that we've looked at it in the last 2 examples. In the last 2 examples, we just had the green part. We didn't have the part below. But there is an additional item with arrays that we have. We don't put it in. It's dictated for us by the system, but I just want to make you aware of it. Here we have what would probably be my grocery list, an array of strings. Now, you notice the numbers at the bottom, right? 0, 1, 2, 3, and 4. Those are what we call indexes, indices, or you may even hear them referred to as subscripts. They identify a specific item in the array. I shouldn't say an item, but a position in the array. So they identify spots where we can either get stuff or put stuff into. The one thing that we need to know about that is all array indexes are 0 based. That means that they all start at 0. So 0 is the first item. 0 is the first item in the list. The last item in the list is always going to be the size minus 1. So let's go back for a minute. Let's go back and take a look at this list. There are 5 items in this list. Bread is the first item. Notice the index of 0. Since the indexes are all 0 based, that means the index of the last item in the list is always the size of the list minus 1. So if we look at grocery list has 5 items. If the first item is always 0, then the last item is going to be the size of the list, which is 5 items, minus 1, which gives us 4. So the last item is always in this list, not always, but in this list is going to be 4. So the valid indexes to get to the items are 0, 1, 2, 3, and 4. And if you count that out on your hands, 0 is 1 item, 1, 2, 3, 4. If you count that out on your hands, you should be holding up 5 fingers. So we do have 5 items. We're just starting counting at 0. There's a reason why I bring this up, because you want to make sure you don't run off the cliff. When you try to access items in the list that don't really exist, we call that running off the end of the list, or running off the array. And we want to make sure that we don't try to access items that are below 0 or greater than 1 minus the size of the list. The nice part about this is we don't have to even know the size of the array. We don't have to remember how many items were put in there, or we don't need to know if somebody gives us an array that we're using. We don't need to know how big it is right off the bat. There's actually a property that can tell us this. All arrays know their size. What do I mean by they know their size? They all have a public property, not a function, but a property called length, L-E-N-G-T-H. We can access it by saying array name dot length. No no parentheses, because it's not a function or a method. It's just a variable, essentially, a public array variable called length. And it'll tell us how many items are in the list. So we can always do array minus 1. So now that we know what indexes are and what an array looks like, let's look at how we can access individual spaces or items in the list. That's going to be what we want to talk about for right now. So it's actually pretty easy to access an individual item, right? We've given the array a name. In this case, we're looking at my grocery list. And each item on that list has an index. You might hear the word index or subscript used. And so, for example, bread is the value stored in position 0 or index 0. Milk is the value stored in position 1. Butter is the value stored in position 5. So if grocery list is the name of this array, then we simply use the name of the array, a set of square brackets, and inside that square brackets is a number. And that number corresponds to a location in the list or in the array. So if I have the statement system.out.println, and for the variable or the value that I want printed out, I supply it with the name of the array, grocery list, and square brackets with a 3 inside the square brackets, that's telling it to look at position 3, index 3, or subscript 3 in the list. And if we look at the visualization of our array above the orange box, we see that at index 3 is stored the value ground turkey. So system.out.println is going to result in the string ground turkey being printed on the screen, or pardon the plane flying over my house, or the string ground turkey being printed to the command line or the screen. So that's great for accessing items, but what about assigning an item, replacing an item, or if we have an empty list, putting an item in that list? How do we go about doing that? To do that, let's look at an array. Let's look at my grocery list array again. Essentially, we're going to do something very similar to displaying. We're going to use the name of the array, in this case grocery list, and the position or index that we want to put the item in, and then we're just going to assign a value to that item. So if we look at the orange box, we look at the code, this assignment code assigns the value ground beef to index 3 in the array, which is the 4th item in the array. So if we look at grocery list and we find the spot, we find the 4th spot, or the spot that is marked with the index of 3, which currently stores ground turkey, and we assign the string ground beef to it. When that line is finished executing, we're going to see, if we visualize that array, if we could visualize that array, we're going to see ground beef now stored in that position. If we look at another example, if we then look at an example of accessing that item, here again we have our array. Notice ground beef is there in the 3rd position now. If we tried to print out what was at the 3rd position, or the 3rd index, we would then see ground beef returned. Now, when we're accessing items from the array, is there anything special we need to know about when we're using an individual item from the array? And is there anything we can or can't do? Well, let's take a look at a list of integers, right? Here I have what an array called student scores. And in that array, I've loaded the values 25, 63, 100, 35, and 7. If this was an actual grouping of test scores, I'd probably be a little concerned. Those scores are kind of low. But they're just integers. So any individual item in that list can still be treated in the same way that we would treat an integer. For example, if I took the value stored at the 4th index of the student scores list, which is 7, I could multiply that by 5 and I would get a number. And I would assign it to sum. And in this case, when that statement is finished executing, the value of sum would be 35. So there really isn't anything different. If we have a list of strings every individual item is a string. We can do all the things with strings that we can do. We can do all the things with an item of that list that we could do with strings. When we have a list of integers, I can do everything I can do to an item of that list that I could do with a regular integer variable. There's nothing that would prevent me from doing that. And that becomes important because we do need to know how to work with these things. The other thing that makes arrays very useful are the fact that we can use loops with them. One of the most powerful things about arrays is the fact that we can process these lists by using a loop, which is why we talked about loops last class. What I want to show you is a setup of a list of values, and the loops that we're going to look at are going to do something relatively simple. They're just going to add all of the values in the list together. We're going to look at a list of numbers. And I've shown you two different ways to do it. One with a while loop, one with a for loop. Both of these, of course, are pre-test loops. But I think that it'll show you how things work. And this is great because it doesn't matter if we have a list of 6 items, 25 items, 35 items, 100 items. We still can write, if we're just trying to add things up, this same code will work, which is what really makes loops really powerful. Let's take a look. So here we have, we're looking at the code in the box, and the first thing we're doing is setting up an array called list, and we're loading it in with the numbers 12, 15, 34, 56, 78, and 102. I've created an integer variable called sum and an integer variable called I. I is going to be our loop control variable because it's going to be the value of I that determines whether or not the loop continues to run. I've set up a while loop. My test is while I is less than the length of the array. And you're probably wondering why. Well, why wouldn't we want to use less than or equal to? Keep in mind that the index is size minus 1, not size. We're not starting at 1, we start at 0. So if we're starting at 0 and we have 6 items, count till you get, just start at 0 and count to see how many fingers that you have. Till you get to 6 fingers, right? 0, 1, 2, 3, 4, 5. Oh, but when I get to number 5, I've got 6 fingers up. I don't want to get to 6. In this case, because we have 6 items, if I get to 6, I've gone off the end of the array and I'm going to get an error. When we run our program, we're going to see an error, and we don't want that. So the way the test is set up, when I gets to 6, we won't do anything. We will never access the. We'll never try to access anything because of the test. So what's going to happen is I starts out being 0. We ask the question: is 0 less than the length of the array? Since the array's got 6 items, list.length comes back with 6. So is 0 less than 6? It is. So we take the current value of sum, which at this point is 0. We add 12 to it because that's what's at list at the index 0 in our list is 12, and we add them together. So sum is now 12. We add 1 to I becomes 2, or I becomes 1. I'm sorry. I becomes 1. Is 1 less than 6? Yes, it is. At index 1 is 15, so we take the current value of sum, which is 12. We add 15 to it. We get 27. We make I 2. At index 2 is the value 34. So we take 27, 34, add the 2 together, add 1 to I, we get 3. Index 3's got 56. So we keep adding, and what you see here is we're just keep adding and adding, and we'll go through, and then eventually I will get to 5. At 5 we find the number 102. So we add that to whatever the value of sum is. We increment I to 6. We come up to our test. Is 6 less than 6? No. So we continue on with the rest of our program. In this respect, we have written essentially, what? Outside of creating the list, we've written 4 or 5 lines of code that have managed to look at all 6 items in the list, add them all together, and store that number in a variable. We can do it with the for loop, which I think is actually a little bit easier, personally. by simply creating that list of 6 items, setting up an integer called sum to store the running total, and then and then all on one line, create I, set it equal to 0. While I is less than the length, we're going to add the current, whatever item we're looking at in the list, to sum, and then increment I. And so we've actually been able to do it in less code. 5 lines total to process all 6 lines of this array and plug it into sum. And that is really what makes arrays powerful. The fact that we can move through every item in the list in sort of an automated fashion really makes, is what really adds some power to these arrays. And the fact that, do I specify an explicit size anywhere? And the answer is no, which means this is really flexible. This loop is really flexible. If I have 100 items in my list, this is still going to work. If I have 500 items, this is still going to work. And so we can write relatively generic code that is super flexible for processing these arrays. We'll see this done in the exercises that we're going to do today, the first 3 of them, which are really the most important for your homework on this unit, are going to be what you'll see, and that this really makes a lot of this. We'll be doing this a lot. As a matter of fact, we'll be using those arrays to do everything, not only find the large and the small, but also, or not only find the sum, but to also find the largest and smallest values. And in your homework, you'll be using that list to figure out what classification that a particular score falls in. Is it an A grade, a B grade, a C grade, or a D grade? All based on this one for loop, which is, like I said, this is what makes loops so powerful. So we've talked about a lot. We've discussed arrays. We've talked about what they are. We've sort of talked about how to create them. We've talked about how to access and manipulate them. And arrays are just a starting point. This isn't the only data structure in Java. There are many other data structures available. There are many other data structures in all programs, in all programming languages. Arrays exist in every major programming language out there. C++, C, Java, .NET. All of them have arrays. All of them have a myriad of other data structures. And so this is really just a starting point for you. If we were in class at this point, I would offer you the ability to ask questions, and we would go through and answer them. However, since you guys are doing this online, of course, if you have questions, please feel free to email me, bsimbeck@ccac.edu. You can bring them with you into class and ask me in class, and I'll be more than happy to answer them for everybody. I'm going to open up some time in the next few classes to answer some of these questions. And otherwise, you can move on to the in-class exercises. I absolutely recommend you complete exercises 1, 2, and 3 before you do your homework. 4 and 5, while not optional, you can do those. There are, again, more uses for arrays, one of which is using a new drawing shape called the polygon. And with that polygon, you provide an array of coordinates. And it draws based on that array of coordinates. So it's very interesting. And opens up even more possibilities. For those of you who are actually wondering, when it comes to database access, we have these structures called, in some languages, called data tables and data rows, especially in .NET. And they're all based on, their basic premise is the array. Their basic premise is the array. So when we get into 130, we'll go into a little more detail, and I think there's even 1 or 2 more data structures that we cover in 130, and then the new class 244 goes into even more stuff. So again, have any questions, please let me know. Catch me in class, email me, bsimbeck@ccac.edu, or choose the email option in Blackboard and choose the option to email your instructors. And I will get back to you as quickly as I can. Otherwise, you're free to move on to the in-class assignments. I suggest that you write those assignments first, walk through them, make sure you understand them, and then you can view the video walkthrough. I hope you enjoyed this program. Thank you.